Hello, students. Today we are going to learn about how to model integer subtraction. So we have spent a really long time looking at adding negative and positive numbers. And now we are going to take what we've learned and we're going to apply it to subtraction and subtracting negative and positive numbers. And just like we started using counters with addition, we are going to start using counters with subtraction. So each of you should have a bag of counters on your table. If you do not, we can pause the video now and pass out those counters. However, remember, we talked about this in the last lesson. Your counters are tools for learning. They are not toys. You should not be playing with them, stacking them, throwing them, knocking them around the room, or you will lose the privilege of using them to help you understand this math lesson. Please leave the counters in the bags on your tables until you are told to try a problem. That way, you can focus and listen without being distracted. So we are not going to take notes together today. Instead, we are just going to practice together using the counters for subtracting integers. So let's go ahead and get started. The first few problems we are going to look at, I am going to do for you. This means you should not have your counters out or should be touching your counters at all during this part of the lesson. So just as a quick reminder, the red counters represent our negative numbers and the yellow counters represent our positive numbers. Together, a red and a yellow counter equals a 0. We call this a 0 pair. So when I'm doing subtraction, I am going to start by putting out the first number in my subtraction problem. So this first number is a positive 3. So I'm going to put out 3 yellow or 3 positive counters. This is not a negative sign. This is subtraction. If it was negative, I wouldn't know what operation to do. So I have to have an operation and a negative or positive sign. So if there's just one sign, think about it as an operation, not as a negative or positive. So this is subtract positive 2. So now instead of adding more like we did with addition, now I'm going to look at what I have and take away from what I have. I have 3 positives. I'm going to take away 2 positives. What I'm left with is my answer. I am left with 1 positive. So 3 minus 2 is 1. I know that there is somebody out there saying, Miss Dunn, we don't need the counters to solve this. I know you don't. Right now, we're simply understanding how we use counters to solve it. You don't have to use counters to do 3 minus 2, but it does help us to understand how to use the counters by starting with a really easy problem. So now, as we move on to a slightly harder problem, hopefully it makes a little bit more sense how we use those counters. So the first number is what I have. It's what I'm going to start with. This number is now negative 3 instead of positive 3. So I am going to start with 3 red or 3 negative counters. This sign is take away, and this sign is negative 2. So now I have a take away or a minus sign and also a negative sign. So I'm not putting in more like I did with addition. I'm taking away from what I already have. I have 3 negatives and I'm going to take away 2 of those negatives. What I have left is my answer. So just like the previous problem, the only difference is I started with negatives and I took away negatives instead of starting with positives and taking away positives. So my final answer is negative 1. So hopefully this makes sense so far. Now it starts to get a little bit tricky because now I'm going to start with positives, but I'm going to take away negatives. And so this creates a problem for us. So looking at the next problem, what I'm starting with is 3 positives. So let's start by getting those 3 positive counters out. This is what I have. And I'm taking away 2 negatives. Look at what I have. Do I have any negatives? Can I take away 2 negatives when I only have positives? This creates a problem. However, if you think back to what we learned, I can add as many 0 pairs as I want. So if I put in this 0 pair to my problem still stays the same. Because now what I have is 3 counters plus 0. And 3 plus 0 is still 3. So by adding in that 0 pair, I haven't changed what I have. And now if you look at this 0 pair, there's a negative that I can take out of that 0 pair. But I'm not going to do that yet because I need to take away 2 negatives. So I need 2 0 pairs. So I'm going to add another 0 pair to my answer. So now I have 3 plus 0 plus 0, which is still 3 counters. But now that I have these 0 pairs, I have fixed my problem of not having any negatives that I can take away. Because now I can take away 2 negatives from the 0 pairs. So I'm going to take away this negative, 1 negative, 2 negatives. The problem is now these positives are no longer zeros. Now they have a value. They are now part of our solution. So 3 minus negative 2 is positive 5. This blows my students' minds because you have been told your whole life that when you subtract, your number gets smaller. But here you see that when you subtract negative numbers, your answer got bigger. And that can be very confusing. That's why the counters help it make sense. You're breaking apart the 0 pairs so that you have negatives that you can take away, making those positives part of your solution. Now, let's look at another example where we have to use 0 pairs to come up with the answer. If you look at the next problem, we are starting with negative 3. I'm going to start by simply putting out my negatives. I'm taking away 2. Remember, this is takeaway. It can't be a negative sign and takeaway. It can only be one or the other. If it's a negative, then I don't know if I'm adding or subtracting. So that has to make it a negative. I'm taking away 2 positives. Again, I have a problem. I only have negatives. How can I take away 2 positives if I don't have any positives? I have to put out 2 positives. That means I have to put out 2 positives with a 0 pair. This does not change what I started with. I still have negative 3 plus 0 plus 0, which is negative 3. But now that I have these 0 pairs, I have positive numbers that I can take away. So now I can take away 2 positives. But these negatives are now not a 0 pair. They have a value, and they have become part of my solution. So my answer to negative 3 minus 2 is now negative 5. I know that these 2 are probably the most confusing when it comes to subtraction. They're also the problems that I see students get wrong the most often. So it's really important that we practice using the counters and understanding the zero pairs so that the answers make sense as to why they go up instead of down, like we're used to seeing with subtraction. So let's take a minute and I want you to talk with the people at your table. Remember why we do this. When you're able to explain what you understand, it helps you understand what you just heard. Please give everybody in your group a chance to talk. Please use your inside voices. The only people that need to hear your answer or be part of your conversation are the people at your table. You should not be using an outside voice. Make sure you are whispering. Make sure you are only talking about the question on the board. When you are done talking about the question, your voices should be off and your eyes should be turned back to the board so that the teacher knows to press play and we can continue on with our video. So the first thing that I would like you to do is turn and talk to the people at your table. Talk about how you use counters to show subtraction of integers. Pause the video and talk about this at your tables now. I hope you guys all had a chance to talk about how you use counters to show subtraction. There are quite a few different things that you could have talked about. I hope someone at your table mentioned that you have to start with counters. Your first number should be the number of counters that you're starting with. Then you should have also mentioned that you are taking away counters from the amount that you started with. Maybe some of you also talked about zero pairs and how if you don't have what you need to take away from on your table, you can create zero pairs and break apart those zero pairs. There is a lot of different ways and things that you could have discussed about how to use counters. Hopefully you were able to put into your own words what you heard Miss Dunn show you on the board. Let's turn and talk to our table one more time. I want you to talk about why can you add zero pairs to a subtraction model. Remember, you should only be talking about the question and you should be using your inside voice. When you're done, turn your voices off and look at the board so that we know you're done with your conversation and we can press play on the video lesson. Please turn and talk to your tables now. So, how much is a zero worth? Nothing, right? You can add zero to anything and it not change your problem at all. Think about a recipe. If you're cooking and you don't add any seasoning to the recipe or to the food, does it change the taste of the food? Of course not. You didn't add anything to it. This is the same way in math. Zero pairs aren't worth anything. They're zeros. So you can add as many of them as you want to your subtraction model and you haven't changed your problem because you're adding nothing. But when you break apart those zeros, that's when it helps you solve the problem. I hope you guys are really understanding this. Now, it's your turn to try some problems on your desk. Okay, guys, so now it's your turn. I want you to take your counters out of your bag and try to solve this first problem on your desk. We're going to pause the video and give everybody a chance to try the problem, and then we'll come back to the video and I'll work it out for you if you get stuck. Not only do I want you to solve it using the counters, but I also want you to use your expo marker and write your final answer using the expo marker after you've worked it out with counters. Pause the video and try the first problem on your desk. So in this first problem, we're starting with positive 4. So the first thing I'm going to do is I'm going to get 4 positive counters out. I am taking away 5 positives. The problem is I only have 4 positives to take away. So that means I need 1 0 pair. So when I take away 5 positive, 1, 2, 3, 4, break apart your 0 pair, 5, I'm left with 1 negative. So my answer is -1. A lot of times my kids look at this problem as 5 minus 4. But remember, in subtraction, order matters. So you can't just turn the numbers around and start with 5 and take away 4. So here you have 4 and you're taking away 5. In elementary school, they might have told you that this is not correct and you have to start with the bigger number. But now that you're in middle school and you're learning negatives, this problem is possible. The answer is just going to be negative. All right, let's try another problem. Pause the video and try number 2 on your desk. So in this problem, once again, we are starting with 4 positive counters. Except this time, we are taking away 5 negatives. This time, I have no negatives on my board to take away. So that means I need 5 negatives through my 0 pairs. 1 0 pair, 1 negative. 2 0 pairs, 2 negatives. 3 0 pairs, 3 negatives. 4 0 pairs, 4 negatives. 5 0 pairs, 5 negatives. Now I have negative numbers that I can take away by breaking apart my 0 pairs. So now I'm going to take away 5 negatives. 1, 2, 3, 4, 5. Now all of these positives are part of my answer. I no longer have 0 pairs. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 positives. So my answer is +9. All right, guys, pause the video and try the next problem on your desk. This time, I'm starting with -4. So I'm going to take 4 negative counters and put it on my workspace. I am taking away 5 counters, 5. I am taking away 5 negative counters, but I only have 4 negative counters. So I have to make 1 0 pair so that I have an extra negative to take away. So now I can take away 5 negatives. 1, 2, 3, 4, 5. What I'm left with is 1 positive. So my answer is +1. I know that negatives and subtraction are a lot trickier than adding. I hope you guys are getting the hang of this, but I do have a couple more problems for you to try on your desk. So let's pause the video and try this next problem on our desk. -8 minus -8. So on this problem, we are starting with 8 negative counters. 1, 2, 3, 4, 5, 6, 7, 8. And we are taking away 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. So our answer to this problem is 0. That was a fun problem. I hope many of us got that problem correct. Let's pause the video and try the next problem with our counters. Remember, even if you're starting to get the hang of doing this without the counters, the point of today's lesson is to use and understand counters for integer subtraction. So please continue to make yourself use the counters and solve it with your answer on your desk using your Expo marker. Let's try the next problem on our desk. 5 minus 8. Hopefully everybody had a chance to try this problem on our desk. So for this problem, we are starting with 5 positive counters. 2, 3, 4, 5. And we are taking away 8 positive counters. But we only have 5. So we are going to use 3 0 pairs so that we have 8 counters that are positive on our desk. Now we can take away 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. We have 3 negatives left. So our answer is -3. I have 2 more problems for you guys to try today. Let's pause the video and try 5 minus -8 on our desks. So for this problem, we are starting with 5 positive counters. 1, 2, 3, 4, 5. And we are taking away 8 negatives, but we don't have any negatives. So I need 8 0 pairs. 1 0 pair, 2 0 pairs, 3 0 pairs, 4 0 pairs, 5 0 pairs, 6, 7, 8. So now I can take away 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. Now, these are not 0 pairs, but they are part of our solution. 5 plus 8. We have 13 positive counters. We have 13 positive counters. So the answer to 5 minus -8 is 13. You guys are doing great. We have one more problem. Pause the video and try -5 minus 8 on your desk now. So for this problem, we are starting with 5 negative counters. And we are taking away 8 positive counters. But we don't have any positives. We only have negatives. That means I need 8 0 pairs to get 8 positives. That's 1 0 pair. That's 2 0 pairs. 3, 4, 5, 6, 7, and squeeze in one more, 8. Now I can take away 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. By taking away the 8 positives, I broke apart my 0 pairs, and they are not 0 anymore. They are now part of my solution. The only difference between this problem and the last problem is I have all negatives. So instead of having 5 positives plus 8 positives, now I have 5 negatives plus 8 negatives. So now my answer is negative 13. So that is the end of our lesson on modeling subtraction with integers, negative and positive numbers, using counters. I hope this really helped us to understand why we use addition when we subtract, and why sometimes when you have negative numbers, our answers get larger. We will continue to practice this tomorrow, and then we will look at some rules and make some connections for those of us who are not seeing the pattern of subtracting without the counters. You guys are doing a fantastic job. I hope you're on your best behavior, and I will see you all very soon.